The question says that a short bar magnet has a magnetic moment of 0.48 joule per Tesla. Give the direction and magnitude of the magnetic field produced by the magnet at a distance of 10 cm from the center of the magnet on the axis and as well as the equatorial lines of the magnet. So if we assume that this is our bar magnet, and we have to find out the magnetic field at a point which is on the axis and on the equatorial line, that is the perpendicular bisector of the magnet. Now, for a fact, we know that a short bar magnet behaves as a magnetic dipole with a magnetic moment m. Now, magnetic field at a point on axis or the bisector or the perpendicular bisector is given by the formula. B on axis is mu naught by 4 pi multiplied by 2 into magnetic moment of the magnet divided by r cube, and on the equatorial position it is given by mu naught m by 4 pi r cube, where r is the distance from the center of the magnet to that point and m is the magnetic moment of the bar magnet. Now, using this formula, we can easily find out what is the magnetic field on the magnitude of magnetic field on the axis and on the equatorial point. So, substituting the formula, we will get the magnetic moment on the axis as 9.6 into 10 to the power minus 5 Tesla, which will be along the magnetic moment, and on the equatorial position it will be 4.8 into 10 to the power minus 5 Tesla, which will be directed opposite to that of the magnetic moment of the magnet. Thank you.